Well, welcome. Today we are going to be working on the second lesson in this algebra course, and we're going to be focusing on two things. We're going to be focusing on order of operations and absolute value. Let's start with order of operations. Now, there's a lot of things in life where we have to follow an order of operations. A perfect example is with cooking. Okay, when you're cooking, you need to follow the recipe. If you mix things up in a different order and throw something in the oven before mixing it together, it's not going to turn out the way it's intended to, and it's going to taste disgusting. So when we follow a recipe, that's an example of order of operations. Even getting dressed in the morning is following an order of operations. I mean, imagine if you went out of the house with you put your pants on first and your underwear over your pants. You're going to look a little goofy and you're going to draw attention. So we need to follow an order of operations even when getting dressed in the morning. So in math, there's going to be an order of operations that we need to follow to be able to make sure that we get the correct answer. So what is that order of operations? Now, my order of operations, the little acronym I use, is going to be a little different than the way that a traditional teacher would use. A common expression is PEMDAS. Maybe you've heard that phrase with, "Please excuse my dear Aunt Sally." Well, I don't like that because P in that expression represents the word parentheses, but parentheses are not always the first things we do. So it really should be GEMDAS. And you can create your own acronym. I don't have anything special. But the reason why we have G instead of P is G stands for any grouping symbols. Because those grouping symbols can be parentheses, but they can also be brackets. They can be a square root symbol. They can be a division line. It can even be an absolute value, which we're going to be learning about later in this lesson. So the first step is to simplify inside of whatever the grouping symbol is first. After that comes our E, which represents exponents. So if there's any exponents involved, we want to do that second. After exponents comes multiplication and division, but the key is it's in order from left to right. That is very, very important. We'll look at an example here in a little bit where that's significant. And the last step is addition and subtraction, but again, it's whatever comes first from left to right. Okay, so you got to remember that. The M and D for multiplication, division, and addition and subtraction, those are kind of grouped together. Let's look at some examples. So in this first example, we have 4 times 3, the quantity 4 times 3 plus 4 squared minus 6. Now remember in the previous video I talked about pausing the video and making sure you write things down. So if you didn't already, go back and pause the video from that previous slide and write down those different steps for the order of operations. And go ahead and pause the video now and make sure that you have this example written down. So as I'm talking about it, you can be doing the same thing. And sometimes I have a tendency to talk quickly. And I do that because this is a video. And you guys can go at your own pace. If I am going too fast, hit the pause button, which for most of you guys, the space bar, if you didn't know that, will pause the video. So pause the video and then just make sure that you're not getting behind. All right. So hopefully you're all caught up with all my jibber-jabbering. All right. So let's look at this one. So we're going to follow the order of operations. The first step is to take care of the grouping symbols. Do we have grouping symbols? If we don't, we can skip it. But yeah, you see we have parentheses. So we're going to do the parentheses first. 4 times 3 is 12. So I would have 12 plus 4 squared minus 6. Look at your notes. What comes next? Exponents. So do we have exponents? Yes, we have 4 squared. So we're going to do that next. So 4 squared is 16. So we would have 12 plus 16 minus 6. Now, the next thing in our order of operations is multiplication and division. Do we have any multiplying or dividing here? No. So we skip that step. So we're going to go to the next step. The next step is to add and subtract in order from left to right. So to do that, we would do 12 plus 16 and get 28. 28 minus 6 gives us 22. So that's our answer when we simplify it. All right, let's look at another one. Now this is something I saw recently online. It was someone posted on Facebook, and it was really interesting to see people's responses because some people did this and forgot the order of operations. They forgot that significant step where when we multiply or divide, we have to do it in order from left to right. So if you remember this trick, you can solve this, unlike what a lot of people were doing on Facebook. So let's look at how we would do this problem. So again, order of operations. First step. What is it? Grouping symbols. So we're going to look. Do we have grouping symbols? Yes, we do. So we're going to take care of the 4 minus 2 first. Well, 4 minus 2 is simply just 2. Do we have exponents? No. So we skip that step. Next, after exponents, multiplication and division from left to right. Okay, so this is where a lot of people were making mistakes online. They just thought it goes multiplication and then division. And so they took 2 times 2 and got 4. And then took 8 divided by 4 and got 2 as their final answer, which would be wrong. All right? So for this one, we're going to start by dividing. And 8 divided by 2 is 4. And now 4 times 2 gives us 8. So 8 is the correct answer, not 2. So that is the importance of order of operations. Now we could also look at other situations with order of operations. Now I'm not trying to get you hungry here or want you to crave a snack, but I don't know about you. Maybe it's just me and my strange mind and how I work. But when I'm eating Skittles or M&Ms, ever since I was a kid, I just would always sort things out. Okay, that's the first thing I'd do. I'd take my M&Ms I was going to get and I would sort them out by color. Why am I bringing that up? Well, there's some times where we have to do that with expressions. Like here we have all these numbers and variables. Well, what we're going to do first is we're going to sort them together. We're going to do what's called grouping together like terms. So you notice some of these terms. Now a term is just one of those pieces that are separated by a plus or minus sign. Each of those are terms. Some of those terms have A's, some of them don't. So we're going to group together those that have A's together and those that are just plain old numbers. We're going to put them in 2 separate groups. So we have our first group here. We would have the 5A, the 4A, and then minus A would all be in one set of parentheses. And then we would have the numbers that don't have variables, the 3, the plus 2, the minus 5, and the plus 1. All of those would be grouped together as well. And so now we're going to work inside of our grouping symbols. So inside of that first group with all those A's, we're going to add those together from left to right. So 5A plus 4A would be 9A, but then we take away an A. Okay, so we like having 9 green M&Ms and we sneak and eat one. So now we would have 8A. And on the right side, we'd have 3 plus 2, which is 5. Then we take away 5, so now we're down to 0. Then we add 1 to 0 and we get 1. So the final expression would be 8A plus 1. So that's how we would do some problem. You're going to see problems like that in your homework assignment. All right, let's move on to talk about something different. Absolute value. Now there's a couple ways we could look at absolute value. I'm going to start by looking at the traditional, the mathematical way of looking at absolute value. So technically, what is absolute value? Well, what it is it's the distance a number is from 0. So we use these 2 vertical lines to represent absolute value. So inside of those vertical lines, I have -4. So we're looking to see what is a distance -4 is from 0 on a number line. So if we created a number line and put -4 on that number line, we would recognize that -4 is 4 units from 0. So what that means is the absolute value of -4 is 4, because it's 4 units from 0. Now what if it was the absolute value of a +4? Well, +4 is also 4 units from 0. So the absolute value of +4 is also 4. Now the way I like to describe absolute value is it's like a car wash. Right? When I have a really dirty car, I drive my car through the car wash and it comes out clean. Now, if I drove a clean car through a car wash, is it going to come through dirty? Absolutely not. Now, it might be a waste of money, and who would drive a clean car through a car wash? But here's where my analogy comes in. A negative number is like that dirty car. When we take a negative number through the absolute value, it's going to come out clean. It's going to come out positive. Now, if I already have a positive number in absolute value, just like if I had a clean car driving through a car wash, it's going to come out clean. So a positive number coming through the absolute value is going to stay positive. Some people make a mistake and they think that the absolute value just changes it to be the opposite. So if I have the absolute value of -4, that became 4. So the absolute value of 4 must be -4. But that's wrong. Okay, so I want to make sure that, so an easy connection, an easy analogy is that car wash example. Okay, so that's an easy way for you to remember it too. So for example, absolute value of -4, the symbol between the lines makes the answer positive, so it'd become +4. So if I had inside of absolute value a grouping symbol 6 minus 8? The absolute, well, we would first do inside the grouping symbol first. So we'd take 6 minus 8, and we would get negative 2 as our answer. And the absolute value of negative 2 would be positive 2. Right? Now, what if instead, if we had the absolute value of 9 minus 3? Again, absolute value is a grouping symbol, so we do inside the grouping symbol first. 9 minus 3 is 6. And the absolute value of 6, it stays 6. All right? So that's absolute value. So that brings us to the end of our lesson. So I hope you understand the concept and the importance of order of operations, and I hope this car wash example might help you understand absolute value a little better as well. So good luck now as you work on your assignments this week.